This is the video for the in-class problem 2005 Alt B2 question. So the question reads, a simple pendulum consists of a bob of mass 0.085 kilograms attached to a string of length 1.5 meters. The pendulum is raised to a point Q, which is 0.08 meters above its lowest position. That's its lowest position. And released so that it oscillates with a small amplitude theta between points P and Q as shown. So it's going to oscillate between here and here, back and forth. So the distance between this point and this point is 0.08 meters. And we're going to use that as an energy problem. So the first question part is going to say on the figures below, and the figures below are going to be these two dots, draw a free body diagram showing and labeling the forces acting on the bob in each of the situations described. Now, easy thing is that there's only two forces. One force is going to be the gravitational force, which is going to go straight down. And it's going to go straight down for both of these. So I'm just going to go ahead and draw that for both of them. Now, at point P, we got to find its point P is right here. So the tension is going up in this direction. So we're going to draw a tension going up and to the right slightly. So we're going to go up and to the right slightly. It's just going to be a little bit more than the gravitational force. Not too much, but a little bit more. And we're going to call that force, tension, tension. Then when we're at the next point, which is at its lowest point, you notice that the string is pulling it straight up. So we're going to make sure that we draw that one straight up. And again, it's got to be just, not too much, but just a little bit longer than the gravitational force, because the next instance, what's happening is that it is going to continue going this. It's going to pull it up and keep on pulling it until it gets to this point right here where it loses its energy, its kinetic energy. All the energy is kinetic. All the energy is potential energy, and then it's going to start up again. All right, so that takes care of that part. It says calculate the speed. All right, well, here's the thing that you may not be aware of, but the gravitational speed, or the gravitational force, gravitational energy, is equal to the kinetic energy. So we're going to say that the kinetic energy, and velocity has to do with kinetic energy, is equal to the potential energy. So we write out, and I'm going to make potential energy in blue so it's easier to see. Our kinetic energy formula is 1/2 mv squared. And our potential energy is mgh. Now, on this, we notice that we have an m here and an m here. They are the same m, so they can be canceled out. And so we rewrite it as v squared over 2 is equal to g times h. So if we want to get v by itself, we're going to have to multiply both sides by 2. So I'm going to multiply by 2 on both sides. And that's going to give us v squared is equal to 2gh. Now the last step is just because we have a square, we're going to get rid of the square by taking the square root, and that's going to give us our final equation, which is v is equal to 2 square root of 2gh. So now it's just a matter of plugging in your values correctly. So we have 2, we have gravity as 10, and we have h. If we look back up here, we're going to find h right here at 0.08. That's the height. That's the height that it falls. So we'll come back and we're going to plug in here 0.08, and then the next step is to use a calculator to calculate it out, which comes out to be 1.26. So our final answer, our velocity, is equal to 1.26 meters per second. And that's your final answer for that part. And then the next part, calculate the tension. We're not going to worry too much about that, so just go ahead and X that part out. And we have our last part, which is describe one modification that could be made to double the period of oscillation. So in order to answer that question, we're going to have to know what the formula is for the period of a pendulum, which happens to be 2 pi times the square root of L over G. Now, that should help guide you, because then what you got to figure out is we can either change the length or you can change gravity. Now, it's a little harder to change gravity. It's easy to change the length, so why don't you try that one? But you could also feasibly change the gravitational field to change the period. Now, understand, we want to double this value. So how would we change the length in order to double it? And that's what you're going to have to figure out. And one clue is, remember that there's a square root here. So the square root of what number is going to give you 2? And that should tell you what to do with the length. I hope this helped.